Good evening, sir.
Good evening, Subhash.
Good evening, sir.
Yeah, good evening, everyone. Good evening, Abhinav.
Good evening.
Good evening, sir.
Yeah, good evening. Okay, so let's continue. Okay, so we will continue with electricity. Yesterday we started with series and parallel combination. So, is there anyone who is finding difficulty in finding out the given terms from a series and parallel combination? Like, see here, mainly three types of questions are asked. You are asked the total current, you are asked the equivalent resistance, you are asked individual currents and individual potentials. That is what is asked in this chapter. Okay. Alright. So I hope the screen is visible to you all.
Yes, sir.
Yes, is the screen visible?
Yes, sir.
sir.
See the circuit. Yesterday we did these two circuits. Just let me show you the circuits which we did. Yesterday we had class at 6:10. Alright. Yeah, so these were the circuits which we did yesterday. This one. Okay, anyone who is finding any difficulty in this circuit?
No, sir.
No. Okay, so you can do.
Yes, sir.
Okay, let's try out a few more questions. We'll do few questions from NCRT also. So first of all, keep these 2 points in your mind that in series combination,
Sir, did you
there
call
will
me?
be- yeah,
Did you call me, sir?
what happened in series combination?
No, sir. Did you call me?
Okay. So we see that in series combination, the equivalent resistance is always greater than the greatest. It is always greater than the greatest resistance. And in parallel combination, and in parallel combination, the equivalent resistance is lesser than the least resistance. So see, what does it mean? It means if I have two resistances, see, let's say a resistance I have a resistance R1 equals to 1 ohm, and I have a resistance R2 equals to 100 ohm. Hmm. So R1 is 1 ohm and R2 is 100 ohm. If I combine them in series, my equivalent resistance will be here. I will get R equivalent to be equal to 1 plus 100, which is 100 ohm, 101 ohm. So this is greater than the greatest. It is greater than 100 ohm. But if I combine them in parallel, so resistance in parallel would be 100 over 101. So it is lesser than the least. The least resistance is 1 ohm, and you are getting the equivalent resistance to be lesser than that. Okay. So this will help us in deciding the equivalent resistance in a number of ways. Okay, without saying the calculations, you can just do those things. Let's try some questions from NCRT. So we start these questions from NCRT here. To see. Okay, just see. No, not this one. Want this series parallel. Yeah, these questions. Just see this question number 1. See this question. You have to draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor, and a 12 ohm resistor, and a plug key, all connected in series. So just draw it, everyone. What all we have to draw here? Aryan?
Sir,
Aryan? Yeah, what all we have to draw?
sir, battery of 3 cells,
Hmm.
5 ohm resistor, 8 ohm resistor, 12 ohm resistor, and a plug key, ammeter.
Okay, so will you be able to do it?
Yes, sir.
Okay.
Sir, with
So
pen.
draw it. Okay. Yeah, draw it just now, everyone. Moksha? Moksha?
Yes, sir.
Okay, draw the circuit.
Okay, sir.
Your circuit should contain 3 cells. So there should be 3 vertical lines of same height. There should be 3 small vertical lines. So these are your 3 cells. The 3 cells should be connected with each other like this.
Sir, do we have to draw an ammeter?
No, we don't have to draw an ammeter. There is no ammeter here.
Sir, then I've drawn the diagram.
Okay. So just okay, show it.
Yes, sir, 1 second.
All those who have drawn can show the diagram. There is one more resistance. You can check. You missed
Sir,
out. There
8 and 12 ohm, right?
only 8 and 12. All right.
Yes.
Okay, write the voltage also. Write the voltage of the battery.
Sir, completed, sir.
Okay,
6.
show it. Show it. Okay, okay, Shubhans. Got it. Moksha, show it.
1 minute, sir.
Sir,
Yes. Yeah. 8 ohm, 12 ohm, and another resistance is
5 ohm, sir.
okay. 5 ohm. All right. And there is an
Sir, I have sent you personally, sir.
yeah, Moksha. Okay, this one is Aryan. Okay, Aryan, just 1 minute. Aryan, there is no battery.
Sir,
Oh, yeah,
battery.
yeah, got it. Yeah, got it. There is battery of 1, 2, 3 cells. All right. Okay, it's correct. It's correct. Okay, for Moksha, I got here. Okay, Moksha, got your answer. 5 ohm, 8 ohm, 12 ohm. Got it. So, Arav, Dharya, have you done?
Sir, doing. So my camera is not working.
Okay, no issues. So let's move on to the problem. I think now everyone can do this. So let's see. Okay, got it. So this you can draw and redraw the circuit of current question 1, putting in an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and voltmeter? So you have to tell the reading of the ammeter and voltmeter. Now calculate the reading of the ammeter and the voltmeter both. So here you have the resistance 1, here you have the resistance 2, the resistance 3. This is 5 ohm, 8 ohm and 12 ohm. Alright. This is 6 volt. You have a key. You have a voltmeter attached to this 12 ohm. You have to measure the potential difference across this 12 ohm and you have to measure the current here. So just make an ammeter here.
Sir, 0.24 amperes, sir.
Okay, so you got 0.24. So you have equivalent resistance R equivalent as 25. The current I will be 6 over 25. So it's 0.24 ampere. What is the potential difference across the 12 ohm resistor? Voltmeter reading. Tumuk, what's the answer? Tumuk,
Yes, sir.
potential difference here across 12 ohm. So this potential difference across 12 ohm, it will be 12.88. So not 12 2.88. You can multiply them. V equals to IR, so it will be 2.88 volt. Now see the next question here. Resistors in parallel, so you have question here. Okay. You just have to judge the equivalent resistance when the following are connected in parallel. So when 1 ohm and 10 to the power 6 ohm are connected in parallel, what is going to be the equivalent resistance?
Sir, it is smaller than the smallest individual resistance.
Yeah, so what will be the answer?
Less than 1 ohm.
It would be approximately 1 ohm. You can check it. Even see, you are getting like 100 over 101. In the similar way, if you have this, so you will have some. If you have 1000, so you'll get 1000 divided by 1001. All right. So 1000 divided by 1001. So this is roughly roughly 1 ohm. So roughly 1, or you can say just a little bit lesser than 1. So you can guess it to be approximately 1 ohm. All right. What will be for this one? Second part, 1 ohm, 10 to the power 3 ohm and 10 to the power 6 ohm.
Sir, approximately 1 ohm, sir.
Yeah, this will also be approximately 1 ohm. So got the answer? These were the direct question. You don't need to calculate. You can find them to be approximately 1 ohm. Now see, an electric lamp of 100 ohm, a toaster of resistance 50 ohm, and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all three appliances, and what is the current through it? Okay, so first draw the circuit.
So second one, no, sir.
Yes. How much?
Second question, no, sir.
Yeah, second question. For the second question only. You have to find. So all the devices, they are connected in parallel. So you have to find equivalent resistance in the parallel combination. So equivalent resistance in the parallel combination will be given as 1 over R P will be equal to 1 over 100 plus 1 over 50 plus 1 over 500. So I think the LCM would be 1 over 5. The LCM would be 500, and you will be adding 1 plus 5 plus 10. So you get
So 60
resistance
by 500 is equal to 331.25 ohms.
500 over 16, right? Resistance is parallel is 500 over 16. So how much is the resistance? 500 divided by 16.
31.25 ohm to 25 ohms, sir.
Okay. So it's 31.25. Okay. Then what is the current through it? Sumuk, what will be the current?
Sir,
Yes.
1 minute, sir. Sir, 7.
How much?
7.
Is it 7? I think it is V, that is 220 volt divided
Sir, it is
multiply
0.142 ampere.
divided by 500. You get,
Sir,
I think, yeah.
It is 0.142 ampere.
No. What is the voltage?
Sir, 220.
220. What is the equivalent resistance?
31.25.
Yeah. So what will be the current? The current will be V over R. 220 over 31.25. So this you are getting 7.04. So the current that will be there is 7.04 ampere. Okay. Now the question is, what is the resistance of an electric iron? So what should be the resistance of electric iron, which is connected to the same source and it takes the same current as all the three appliances. So what should be its resistance?
31.25.
Yeah, 31.25. Okay, question 3. What are the advantages of connecting electrical devices in parallel?
Sir, one of the advantages is that if one of the devices does not function properly, the others will.
Yes. So if one of the first of all the devices they can be operated separately, and if even if one of the device fails, the other devices will keep on working. The third benefit is that there is no potential drop. There is no voltage drop occurring across any of the devices. If they are connected in series, so there will be potential drop across each resistor. Okay, now question 4. How can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm? So how can you connect them to obtain a total resistance of 4 ohm?
Sir, we can connect in series with the parallel combination.
Yeah, draw this circuit and then show. Everyone, draw the circuit for this one. How can three resistors of resistance be connected? This question I want. All of you draw the circuit for this. Shubhans, are you getting?
Sir, can you repeat? Sir,
This question, yeah, you have to draw the circuit for this.
yes, sir, I'm doing it, sir. One second.
Okay, see. So you have to obtain an equivalent resistance of 4 ohm, which is less than 6 ohm. So your 4 ohm is less than 6 ohm and it's greater than 2 ohm. Alright. So I think if I connect them, how do I get them to 4 ohm? Which one should be kept in parallel? Which one should be kept in series?
Sir, in series, we need to take 2 ohms, and in parallel, we need to take 3 ohms and 6 ohms.
Okay, so what will be the equivalent of them? So
4
you get
ohms,
this
sir.
one. Yeah. So this 4 ohm is greater than 2 ohm. For this region, we are getting 2 ohm in the series connection, and it's less than 6 ohm and 3 ohm. So we are taking 3 ohm and 6 ohm in the parallel combination. Alright. So by this logic, we are able to justify. And if you see here 3 ohm and 6 ohm, so you can obtain the equivalent. The resistance in parallel would be 18 over 9, which is 2 ohm. Alright. And the total resistance comes out to be 2 plus 2, which is 4 ohm. Then how will you get an answer of 1 ohm?
Sir, by keeping all resistors in parallel.
By keeping all resistors in parallel. Okay, so you obtain, since it is even less than 2 ohm, so you have to use 2 ohm in the parallel combination.
Sir, it's not 18 by 9, right? In parallel.
Which
It
one?
should, it's not 18 by 9. I guess it should be 1 by 3 plus 1 by 6. So that
Okay,
would be
yeah,
12
solve
by
it. Okay, if you get it 1 by 6 plus 1 by 3, your LCM would turn out to be here 6. Okay, and this you get here 1 plus
2.
2. So you get 3 over 6, which is 1 over 2, and this was 1 over r. So you get r equals to 2.
Okay, sir.
It is-
Got it.
Okay.
Got it.
Now see how I got this. This is a shortcut also. You can also use this. The shortcut is that you can find the resistance in parallel of the two resistances by taking R1 times R2 divided by R1 plus R2. So you can add the two resistances, R1 plus R2 you can obtain, and here it will be R1 times R. Got it? So
Yes, sir.
this is a shortcut, you can use it. For if the numbers are small, so you can say 6 times 3, that is 18, divided by 6 plus 3, that's 9. So answer is 2. Then the last, if you connect all of them in parallel, you will get this 1 ohm also. Now, what is the highest and the lowest total resistance that can be secured by combination of 4 coils of resistance? So you have these 4 resistances. What is the highest resistance that you can make? Yes. What is the highest resistance?
48 ohms.
48 ohms. The highest resistance R will be in series combination. That you just add them 4 plus 8 plus 12 plus 24. So this is 48 ohm. And what is the least resistance?
1 minute, sir, solving.
Yeah, solve it. So least resistance is possible when they are connected in parallel combination.
Parallel.
Sir, 2 ohms.
Okay. The answer is you obtain 1 by R to be 1 over 4 plus 1 over 8 plus 1 over 12 plus 1 over 24. LCM being 24. So you get here 6 plus 3 plus 2 plus 1. So 12 over 24. Yeah, the answer is 2 ohm. Alright. R we get as 2 ohm. This is the minimum resistance that can be secured. All right. So I think we can move on to the next topic. Or do you need any other practice for these questions? Try one more question here. From the next class, we'll start with electric power. This is 6 volt, 1 ohm, 2 ohm. Here you get 2 ohm and 1 ohm. So This is part A, B of the circuit, and this is point C. All right. So what all you have to find out here? You have to find out, of course, the equivalent resistance. So you have to find here the equivalent resistance. Everyone do this. Find equivalent resistance. Then total current drawn from the battery. You have to find current through 1 ohm resistance, current through 1 ohm. Then you have to find current through, sorry, you have to find current through AC. You have to find potential difference. Potential difference across AC. So these are the questions which you have to answer. Okay, anyone got the answer? Sumuk, what is the equivalent? Siddhisri. 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 Again, I think you are not able to respond. Aryan?
Yes, sir.
Hmm.
Equivalent resistance.
Okay, what the equivalent resistance?
Sir, 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3.
But what's the equivalent? How much do you get?
So is this 0.83?
No,
Sir, 2. Oh, wait. 1 by 2,
no,
sir. 0.5.
no.
Sir, 4 resistances are there.
Hmm. So see here, we see that there are two lines. From where it's getting distributed in two lines.
Sir,
So
1 by 3, sir.
it's not 1 by 3. The upper portion and the lower portion. In the upper portion, 1 ohm and 2 ohm, they are connected in series. In the lower portion, 2 ohm and 1 ohm, they are also connected in series. So the equivalent for these two will be 3 ohm, and the equivalent for these two will be 3 ohm. All right.
Sir,
Then
is it 2.1?
no. Then you find the parallel equivalent for it. The parallel equivalent for this will be 1.5 ohm. So this whole circuit is 1.5 ohm. 1.5 plus 1.5, this 1.5 is in series. So 1.5 plus 1.5 makes the total resistance to be 3 ohm. And hence the total current I will be equal to 6 over 3, which is 2 ampere. Then you have to find the individual current, that is current flowing through AC and current flowing through PD across AC. So take a screenshot of this. This will also be added to this content page. You can attempt this homework question. Got it?
Okay, sir. Bye, sir.
Okay, bye.
Yes, sir. Bye, sir.
Just try this question as a homework. Okay, yesterday did I give some homework?